My name is Simon. I am the co-founder and current general manager of Confio. Confio is a development company behind CosmWasm, smart contracting framework in the CosmWasm system. One of the USPs of CosmWasm is that it is an application framework that allows you to build IBC apps. And CosmWasm, for the reason it's not really known to be the best way to build IBC apps, but I think actually that's what it's best at. We talk a lot about cryptography and things like WebAssembly, the actor model. We don't have very common issues of re-entrance engine. We have all of that in the smart contract re-engine. But where what is really shining is building IBC applications. So we have IBC support since 2021. We are able to send ICS 20 IBC tokens through IBC, but also you can build your custom protocol. So you can have one contract on one chain, one contract on another chain. They agree on a contract, on a protocol that nobody else cares about, and they just communicate. No standardization process. You can iterate this protocol at the end of every sprint cycle of your app development. So with that, we can do contract-to-contract communication, but we can also do contract-to-native Cosmos module communication, which is something that we have shown with contracts that implement the ICS 20 protocol, but also we have people in the community who implement Interchain accounts with Cosmos contracts. That being said, today I'm going to talk about two different things. One is IBC callbacks, or ADR8, which is the specification of the IBC team. And the other one is asynchronous acknowledgement. Those are two major improvements for advanced usages of IBC in CosmWasm, but they are pretty independent of each other. So you can use one but not the other and combine them any way you want. So we start with IBC callbacks, which is really about getting notified when there's a package delivery. So think about, okay, you order something on an online shop, you get this package, it's transferred to you, and then you want to know, so the retailer, the one that sent you the package, wants to know, did it arrive? And also, if you're not at home, but somebody, I don't know, maybe your neighbors are there or your wife is there, you want to know, has that been delivered? You want to get notified. And those are basically the two things that we can get notifications about in IBC and IBC callbacks. So brief recap how an IBC packet flow works. So we are going to get back to this diagram a couple of times. So the basic structure is important to understand here. So the time goes from the top to the bottom. On the left, we have chain A. On the right, we have chain B, and then the relayer and off-chain service in between. And the way IBC basically works is there's a packet created on chain A. The relayer receives that packet, reads it, and submits a transaction on chain B, where the packet is then delivered. There, during the delivery, an acknowledgement is created. The relayer comes back in, sees the acknowledgement, and sends it back to chain A, so the chain A knows, okay, there was the successful delivery. So it can get up very complex. If we want to look at all the edge cases, notes that we found. Now, IBC callbacks is basically notifications on those two events. First is the package that we received on the destination chain, which we call destination callback. And the other one is the source callback, where chain A gets, or someone on chain A, some module gets notified that the acknowledgement has been written by a chain. So we're going to look into those two cases. What I'll do here. Destination callbacks is about informing the recipient. So yeah, it's really from the perspective of the package. It receives the destination, and now certain modules, contracts want to get notified that this happened. So the primary use case is to inform the receiver of incoming tokens that they got tokens. So if you send tokens from one chain to a contract on another chain. And, okay, those tokens get added to their balance, but maybe the receiver wants to do something with those tokens. So, for example, if we build an IBC sync contract is something very simple. It receives tokens and it burns them. So this is a way to destroy tokens, very, very simple. You can do that on one chain, where you just say, okay, everything was sent to my contract, I'm going to run it. And we can do the exact same thing with destination callbacks via IBC. It's just a contract that receives tokens, and by getting notified when you got tokens, can then perform an action, such as burning those tokens or doing something useful. But that's up to your imagination. The information that you get in a destination callback is pretty much the packet data, everything that is in there, and the acknowledgement value that has been created. And those destination callbacks, they are only called pretty much on success, or if there's an acknowledgement, there's a timeout. So there's timeout that's pretty much nothing happening on the destination, so you don't get informed about those things. But you see that well with that. For destination callbacks, you have to be very careful with what you're getting, because a destination callback can inform any address on the destination chain that something happened. So someone else might send you a notification about something you don't care about at all, just because they put your address there. So if you receive a destination callback, you might get it from an application that you have nothing to do about, what to do with. And this is something that might be used to attack your contract. So you have to check the port where the callback is coming from, or where the packet is going through. You can decode and check the acknowledgement value. So, for example, for an ICS-20 token transfer, we can look for this 1 byte to see, okay, is this a success or is this some damage? And you can decode and check the packet to look into the individual fields to figure out if this is what you're expecting. So in code, it looks like this. If you have ever written or seen a CosmWasm contract, this is very straightforward. So we start with a new entry point and the top level of contract, which is just the function IBC destination callback. And we have this entry point feature there, which does all the magic to make this entry point accessible by the host environment. So what we do there is what we talked about before on the other slide. We check that the port of that package that this coming through is the transfer port, which is the port that we expect ICS-20 packets to go through. We check the acknowledgement data to make sure, okay, it's in a certain format and it's contained this 1 byte value. And then we can decode the packet data. So now we have a sense of, or we know what kind of protocol we are expecting. So we know how to decode the packet data. And this step is really protocol specific. That will be a different code for a different type of protocol. This is ICS-20 version 1. But if you have a channel that has ICS-20 version 2 or Interchain accounts or anything custom, then this decoding step will be completely different. So for example, it might not be JSON, it might be some other binary encoding, and the structure can be different. So you can decode your packet, and what that allows you to do is get this receiver field here. And that is a protocol specific value for the receiver of the ICS-20 transfer. And then what we do is we check that the receiver that we decoded is the same address as the contract that is getting this call. Otherwise, we, in this example, don't want to bother about those callbacks, so we just error and say, oh, that's not our problem. Now, the third part is after you did all those nice checks, you can do something with those incoming packet. So in this case, we're still in the FICS 20 example, and we check the denomination of the token that was sent, and then we take the incoming funds and use a message sent to send them to a different address. So we pretty much just forward the funds that received here in this example, which is something that was not possible for IBC programs. The other half of callbacks is source callbacks. So that is informing the origin of the packet. So this chain A on the left side, that if we got an acknowledgement or a timeout, when the primary use case is to get information about this transfer message. So in the contract sends IBC tokens to some other destination or some other address on another chain. It wants to know at some point, did this send succeed or fail? Because that might then trigger follow-up steps. If I know this transaction has been sent, then I can continue my processing. If I know it failed, okay, then maybe the contract can do something smart. Maybe it can retry. Maybe it can take another route. It can take another channel of payment. It can inform other systems that those operations did not succeed. But yeah, due to the asynchronous nature of IBC, it cannot know at the point where the packet is sent. It's to be informed about those information. And yeah, here we don't have that much trouble with checking where the callback is coming from, because we know the system is ensuring that the callbacks only are created for packets that are emitted by the very contract that is receiving the call. So in code, it looks like this. We have another entry point, which is IBC source callback, very similar structure. And what you then have is this message, which is an enum, which only has two cases. So you have the acknowledgement case, the packet was acknowledged on the other side, of the timeout case, where the packet has timed out. So in this timeout variable, there's a bunch of information. So there's acknowledgement data, the original packet, the address of the relayer. So you can process this data in your application to a specific way, make sure you can do something slotted. And that's pretty much it for IBC callbacks, destination callbacks, source callbacks. Pretty straightforward for the contract development. The second chapter is asynchronous acknowledgement. And that is pretty much the idea the recipient of a packet creating an acknowledgement, not in the very moment the packet arrives, but at a later point in time. I have this slide here that I borrowed from the presentation from Jack last year at Nebular Summit, where packet forward middleware is explained. And the way this works is you have incoming tokens that are received by this forward middleware or this first block. And this first block is not sending an acknowledgement right away. It needs to wait until those operations on the right side completed in order to be able to do the step number 9, sending the acknowledgement. And since all of this process is asynchronous, and all of this is between multiple chains and taking time and blocks, you really need an option to delay the creation of the acknowledgement. And then later, when all of this happened and you're coming back all this loop, then you have the ability to manually create the acknowledgement. What this allows us pretty much to do implementations like that, not only in Go as a native module in a Cosmos chain, but you can implement packet forward middleware as well as similar systems. So in order to get to asynchronous acknowledgements, we have broken down the development into 2 steps. The first one that we released in CosmWasm 2 is making acknowledgements optional. So when you receive a packet, you can choose as a contract to not create an acknowledgement. You just say, no, there's no acknowledgement. And that allows you to write protocols that just never write an acknowledgement. I'm not saying that this is a wise thing to do, but it's possible. And it's preparation for them later writing the asynchronous acknowledgements explicitly manually. And then in CosmWasm 2.1, which has actually been released yesterday, so this is usable now, we have this extra IBC message write acknowledgement. And that allows you to later, a couple of blocks later, write this acknowledgement that you have not written when the packet was received. And with that, you can implement packet forward middleware in contracts, which is what we've seen before. But what you can also do, which I think is an interesting example that I came across in a side project, you can do a long hauling for interchain queries. So the way interchain queries work is you send a packet which contains a query request, and the acknowledgement of that packet is containing the response for the query. So instead of having 2 packets, one sending the request to the other chain, getting acknowledged, and then the other chain sending the response back as a separate package and getting that acknowledged, you will reduce the network bandwidth by half by just saying, okay, the acknowledgement of that first request contains the response. But there are cases where the response is not immediately available. Maybe you need some time to get that response. So you can do something that we know from websites when we, for example, load a website, but the server does not yet have the response ready. It keeps the connection open and keeps the request pending. All the nice wheels are spinning. And once the result is there, it then sends the response and you immediately get the response. And we can do that with interchain queries with write acknowledgement, because the destination chain just continues to rule the flux. And then once the result is there, the acknowledgement is written and you get the response ready. So the way this looks in code is optional acknowledgements. First of all, just writing no acknowledgement. We have CosmWasm 1 on the first side, on the left side, and CosmWasm 2 on the right side. Initially, it was very easy to create an empty acknowledgement by just saying, receive response new or default, which is something that you never want to do, because you create an acknowledgement, so that is empty data, which is completely pointless. So in CosmWasm 2, we decided to make it much harder to shoot yourself in the foot. So when you create a receive response, you always have to pass an acknowledgement. That can be something valid in the top or an empty one. But now in CosmWasm 2, you also have the option to say without pack. And that is pretty much very explicitly saying, no, I do not want to write an acknowledgement. And I'm very explicit about it. And yes, I really want to do that, which is not the common mix. In code, it looks like this. On the left hand, that is CosmWasm 2. You have the acknowledgement when you create a response. While you say, okay, I don't want that. Now, going back to this flow, we have in line number 3, we just look at line number 3 now. We receive the packet and create an acknowledgement. We can write this down into 2 steps. Receiving the packet, we create the acknowledgement. And if we have those as 2 different steps, we can produce a couple of blocks in between. So we split that into 2 things. And the way this works in code is just for someone who's familiar with writing CosmWasm logic, it's really straightforward. It's very simple. You just emit CMS private acknowledgement, which contains the acknowledgement as the last field that we have. And then you put the channel of the packet sequence in order to specify which packet you actually acknowledge. And that's it. Really straightforward. I mean, we don't have an example from this yet, but if you have ever written with CosmWasm smart contract, you can imagine filling those three fields is pretty straightforward. So yeah, I've got built all this myself. I should pretty much look nothing like myself. So I really want to thank Chris from Confio for implementing all that. Sana has been a massive help from the IBC team. IBC Hooks is a project that preceded IBC calls, so it has been CosmWasm team have really pushed this idea much more faster than the ecosystem could keep up with. And then, Confio and the IBC team collaborated on the AR dates with a bunch of people that's on our team, on that team. Yeah, this has been a long process. Maybe just finalizing stuff. There are a few more cool things in CosmWasm 2.1, which again we released yesterday. So we have SecP 256R1 verifier to be able to verify passkeys. With the last 12, we had one verification that allows you to verify new and grand frequencies as well as long words. We have a new Wasm version. It's a better migration process. So watch out for CosmWasm 2.1. It's a massive feature release following the breaking into the door. And that's it. Thank you. Sure. You got time for questions? I'm very happy to take them. Otherwise, yeah, awesome. Yeah, questions? And it's very listening to you guys. You guys are very happy. We're saying so sensitive right now. So right now we see a massive amount of applications that are using IBC hooks, and we want to get them over to the environments and all that. It's pretty much all of those uses.
We are from the Knowles team. And, so far, we have been using the Interchain transactions module by Egyptian, but we'll migrate to using IBC.
Yes.
Yeah, clarification. So when I write the acknowledgement with the wrong packet ID, what happens?
Most likely the system will tell you that it's either not your packet, so you're not allowed to do that, or if you try to write an acknowledgement for something you wrote an acknowledgement before, you'll also get an error. So you cannot override an acknowledgement that has been written before. So there's a bunch of safety checks in the environment. The contract developer doesn't need to worry about too much. But yeah, those basic cases I have not in one day.
Thanks.
Is there a specific version of the SDK wasn't that we can access as well as you want?
Yeah, so this functionality has been implemented in Wasm 52, which we released yesterday, and that is a version that is compatible with CosmWasm SDK 050. There are no more questions. Happy to wrap it up and get the next speaker, Sadie.